Okay, so this next lesson goes over zeros of a function. Zeros have multiple names, but in the definition of a zero is graphically, it's the point at which the graph intersects the x-axis. And remember, the x-axis is that horizontal axis. So when we're trying to find the zeros, we're looking for where the graph crosses the x-axis and what points there are. We're just going to list them. Algebraically, which we'll talk about in a minute, is when the points, whenever we set the equation equal to 0. So we'll show you that on the graph side of it in our calculator. Zeros have multiple names. So X intercepts is the most obvious. X intercepts meaning where it intercepts the x-axis, but it has 3 other names that the EOC could really ask about: zeros, roots, X intercepts, or solutions. Okay, if you remember the term ROXS, okay, I know it's not grammatically correct, but if you remember the term ROXS, it's roots, zeros, X intercepts, solutions. So it's a quick little reminder on how to remember those names. So if we're given a graph, which is these 6 examples right here, graphically, all we are looking at is where does it cross the x-axis and what's that coordinate. So I'm going to show you the multiple ways to write it, but so number 1, if I look at this line and I look at where it crosses the x-axis, it only crosses once right here. So this point is 2, 0. Okay, so I would list the coordinate. Another way to write it would be x equals 2. Okay, so both would be correct. Number 2 is, so we look at where it crosses the x-axis, and it crosses the x-axis twice here. It crosses here and it crosses here. So we would list the coordinates. So this is -2, 0 and 1, 0. Or we can list it as x equals -2 and 1, comma 1. Okay, different ways to write the same idea. Number 3, it crosses the x-axis twice here, so here and here. If we wrote it out as coordinates, it would be -3, 0 and 4, 0. If we were to list them, it would be x equals -3 and 4. So either way you want to write them. Number 4, it crosses the x-axis twice. I know it's hard to see this, but the x-axis is actually this line right here. I know the shading's a little off, but it crosses here and it crosses here. So the coordinates would be -3, 0 and +3, 0. Another way to write that would be x equals -3 and +3. Okay. Number 5 also crosses the x-axis twice, here and here. The coordinates would be -1, 0 and 0, 1, 2, 3, 4, 0. Or we could list them by doing x equals -1 and +4. Number 6, this graph crosses the x-axis 3 times, once, twice, and thrice. So if I were to list these coordinates, it would be, make sure you know where the 0, -1, -2, -3, -4, -5, 0. The second one is at the origin, 0, 0, and the last one is at 2, 0, okay? And then to list them out, it would be x equals -5, 0, and 2. So whichever way to write it that we give you on the assignment, that's the way to go. Okay, so if we are going to do this algebraically, this means by hand, okay? All we are doing is setting the equations equal to 0. So what I mean by that, so step 1 is replace f of x with 0, okay? And then step 2 would just be to solve for x. So if I look at number 1, we're going to replace f of x with 0 equals 4x minus 8. And then we're going to use our solving equation skills that we learned at the beginning of the year to get x by itself. So we follow SADMEP, remember. Okay, I take care of any subtraction or addition first. So the inverse of subtraction is to add 8 to both sides. 0 plus 8 is 8 equals 4x. Then I take care of any division or multiplication. So I would divide by 4. 8 divided by 4 is 2 equals x. And there's my answer. Okay, it has one solution there. Number 2 is we're going to do the same thing. We're going to set equal to 0. So replace f of x with 0 equals 2x plus 2. SADMAP tells me I take care of addition first. So the inverse of addition is to subtract 2. 0 minus 2 is negative 2. And then I have 2x because those 2 cancels. Then I take care of any division or multiplication. The inverse of multiplication is to divide by 2. Negative 2 divided by 2 is negative 1 equals x. One solution there also. Number 3. Replace f of x with 0 equals negative x plus 7. I would take care of any addition and subtraction first. So the inverse of addition is to subtract 7. I have negative 7 equals negative x. A lot of people like to stop here, but I don't have x by itself yet. I have negative 1 times x. So the inverse of multiplication is to divide by negative 1. So negative 7 divided by negative 1 is positive 7 equals x. So what this means, I forget to go over it, is if I were to graph these would cross the x-axis. This one would cross the x-axis at positive 2. This one would graph the x-axis at negative 1. This one would graph it at positive 7, and so on. So number 4, if I set it equal to 0, I have 0 equals 2/3 x minus 6. Subtraction and addition first, so I take care of subtraction, which the inverse is to add 6. 0 plus 6 equals 6, 2/3 x. Technically, I would divide by this fraction. Dividing by a fraction is the same thing as flipping it and multiplying by the reciprocal. Oops, that's not the reciprocal. Flipping it and multiplying by 3/2 to both sides. 6 times 3/2 is 9 equals x. Number 5, set f of x equal to 0. So I have 0 equals 1/2 x plus 2. SADMAP tells me I take care of any addition. So the inverse of addition is to subtract 2. 0 minus 2 is negative 2 equals 1/2 x. Again, I would technically divide by a fraction, but dividing by a fraction is the same thing as flipping and multiplying by 2 over 1. So 2 over 1 times negative 2 is negative 4 equals x. Last one on algebraically, 6. If I set f of x equal to 0, I have f of x 0 equals negative 2/5 x plus 4. I take care of subtraction and addition. The inverse of addition is to subtract 4. 0 minus 4 is negative 4 equals negative 2/5 x. Technically, I would divide by a fraction, but the dividing by a fraction, the rule is you flip it and multiply. So I'm going to flip it and multiply by negative 5/2. So my answer is positive 10 equals x. Okay. Technically, you could write these as coordinates. So if x equals 2, that means the coordinate would be 2, 0. If x equals 7, the coordinate would be 7, 0. If x is negative 4, the coordinate would be negative 4, 0. If x was negative 1, it would be negative 1, 0, 9, 0, and 10, 0. So you could see it written both ways. Okay, so technically, we could still solve these algebraically, but that goes into rules that we're not going to learn until the second semester. So we're going to teach you how to do it in your calculator, okay? Especially when we're dealing with higher exponents. So rule of thumb, if you want to know, this is my tip to my kids, is to figure out, before I type it in my calculator or anything like that, I want to look at the equation and see how many possible zeros there are going to be. And when I say possible, I mean possible. It doesn't mean exactly. So what you look at is you look at the highest exponent. Okay? The highest exponent is the number of zeros that we should expect. Now, I'm not saying you're going to get that number of zeros. It's just we should go to look for them and see if there are actually that many. But it could be up to that many. So I'm not saying they're going to go all the way to the highest exponent, but there could be. So I'll show you some examples. So what we're going to do is type these equations into y equals, okay? All right, we're going to type each equation into y equals. So if I look at number 1, the highest power, the highest exponent is 2. That means I should be looking for 2 zeros. So if that's what I want to look at when I'm typing this in. So if I type it into y equals, I do x squared minus 16, okay? And we're going to do the same thing where we set it equal to 0 here, okay? So I'm going to put in the second equation, I'm going to put 0. And we're going to graph it, okay? So as I look at it, we see that it's a parabola here, and it does cross the x-axis twice, so that higher power was correct. It has 2 zeros. Now, I can visually see what those 2 zeros are, but there are going to be times where it's not going to come out to a nice pretty number, so that's why we put 0 into y2. So I'm going to show you a little trick here. We are going to tell the calculator to find those two intersections right there, okay? So the first thing we do, it's a combination of 5 buttons. We do second trace, okay, I say again, second trace, 5 for intersect. And then we want to move the cursor closer to the intersection that I'm looking for. And then we're gonna hit enter 3 times. Enter, enter, enter. And it gives me that intersection, what that 0 is. So the first 0 is -4, 0. Okay, but that's just the first one, so we're going to go to the right side this time. So I'm going to go again, second trace 5, and I got to move my cursor. Hold on, let me do it again. Second trace 5, I got to move my cursor over to the right, close to this intersection, and then enter 3 times. Enter, 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 and this time it gives me this X intercept, and that's positive 4, 0. So my prediction was correct. There were 2 zeros, and they were -4 and +4. So you could see it written as coordinate ordered pairs, or you could see it as x equals -4, +4. Both would be correct. Okay, let's do it again. So I go to y equals, I type in the equation that they want me to find. So 5x squared plus 5x minus 30. I'm going to set it equal to 0, okay, because we're going to look for that intersection. I hit graph. As it's loading, let's see what we could predict to see. So the highest power tells me that there should be 2 zeros. Will there be? Not always, but let's see in this case. So if I look at it, there are 2 zeros. And that's the max that there can be. So there's not going to be any more anywhere else. But there could be 2 here, and there are 2. So visually, I can see what they are, but we want to make sure mathematically we know for sure. So again, we're going to do 5-button combination. Second trace 5 for intersect, and then we're going to scroll to the left because I want to be close to this intersection. Enter, enter, enter 3 times, and my first intersection, my first 0 is -3, 0. Then I'm going to do the exact same thing, but I'm going to go to the right side. So second trace 5, push your cursor all the way to the right, and then enter, enter, enter. And that intersection, or that 0, is 2, 0. Okay? So I could see it written as ordered pairs, or I could see x equals -3, +2. Both are correct. Notice I don't put these in parentheses because it's not an ordered pair. I'm just listing what the zeros are, so we don't put them in parentheses. All right, number 3. If I make a prediction, I am going to assume that there should be 2 zeros because the higher power is 2. So let's see if we're correct. We're going to go to y equals, type it in, -x squared minus 2x plus 24 equals to 0, like this one. Hit graph, give it time to load. So there's 1 0 there, and there's the second one. So there are 2 in this case. Then it's the same button combination. Second trace 5, and then I'm going to go to the left to get to the left side. I want to get as close as I can to this intersection. Enter, enter, enter. And the first 0 is -6, 0. I'm going to do the same exact thing, but I'm going to go to the right side. So second trace 5, push your cursor to the right by holding the right arrow. Get as close as you can, and enter, enter, enter. Your intersection there, or your second 0, is 4, 0. Or I could write it as x equals -6 and +4. Okay, so we're literally just going to do this for the rest of the problem, so bear with me. Number 4, okay, I can predict that there should be 2 zeros, so let's make sure that's correct. If I go to y equals, I clear there, and I go x squared plus 7x minus 8. I go to graph. Let's see if there are 2. There's 1 there, and there's 1 there. So then I want to get close to this left intersection, so second trace 5, push your cursor to the left, and then as close as you get, enter, enter, enter. And my first 0 is -80. And then I do the same thing, second trace 5, go to the right. Make sure you go to the right side because otherwise it's going to read that left one again. Get close to this one and then enter, enter, enter. And my second 0 is 1, 0. Or I can write it as x equals -8 and +1. Okay? If we continue, number 5 has 2, the higher power, so that means I should expect 2. So let's see. X squared minus 3x minus 28. Hit graph. There's 1 and there's 2, so there are 2. Then I do the same thing, second trace 5, go over to the left as close as I can get to that intersection, enter, 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 and the first 0 is -40. The second 0, second trace 5, go over to the right. Takes a while sometimes, enter, 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 and the second 0 is 70. Or I can list it as x equals -4 and +7. Number 6, the higher power is 2, so I should expect 2 zeros. So let's see if we can type this in. -x squared plus 7x minus 10. Hit graph. Give it time. So there's the first one and there's the second one. That was a quick turnaround. So I do the same thing. Second trace 5, go to the left. Oh, no, went too far. This time I had to go to the right for some reason. Okay, enter, 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 and then my first 0 is 2, 0. The second one, second trace 5, I go to the right, enter, 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 and the second 0 is 5, 0. So this would be x equals +2 and +5. All right, if we start looking at it, the powers get higher. So this one, the higher power is 3. So that means I should expect 3 zeros. So if I type them in, I have x to get the 3, to get the cubed, you do caret, I call it carrot top, raised to the power of, that's underneath the clear button. And then you pop up a 3, but you need to remember to hit the right arrow. -5x squared plus 2x plus 8. You hit graph. And I should be looking for 3. Will there be 3? Not always, but oh, there they are. So there's 1, 2, and now 3. So that means I have to do this 3 times. Second trace 5, and I go to the first one first, as close as I can get. The first one is -1, 0. Then I go again, second trace 5, and I go to the next one. Enter, enter, enter. The second one is 2, 0. And then I go to the last one, second trace 5, get as close as I can get. And the last one is 4, 0. So there were 3, which means you have to do it 3 times. Or I can write it as x equals -1, 2, and 4. Okay. Number 8, same thing. The higher power is 3, so I should expect 3. So let's see if we do. If I type it into y equals x raised to the power of 3, hit the right arrow, plus 2x squared minus 15x. Graph it. There's 1, there's 2, there's 3. So we're going to do this 3 times after it's done loading. Okay, second trace 5. I want to get close to this first one. Any order matters, but I like to start from left to right. Enter, enter, enter. The first one is -5, 0. Second trace 5, then I go over to the next one. Enter, enter, enter. This one's 0, 0 because it passes the origin. And then again, second trace 5, scoot over to the right some more. Enter, 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 and that's 3, 0. So there were 3 of them. I could also write it as x equals -5, 0, and 3. Okay, 2 more. Number 9, the higher power is 3, so that means I should expect 3. So let's see. 3x to the power of 3, right arrow, minus 3x. Graph it. There's 1. Oh, there are 3, but it's really, really tight in there. So let's see. I know visually you can see these. You can tell what they are on the x-axis, but we're just going to triple check by doing it in our calculator. So second trace 5. I want to get close to this left one. The first one is negative 1, 0. Then I do it again, second trace 5, but this time I want to get close to this one. And that's 0, 0. And then the last one, second trace 5. I want to get close to this 0. And that's 1, 0. So those were really close together. Then I can write it as x equals negative 1, 0, and 1. Last but not least, this one has a power of 4, which means I could expect 4 x-intercepts. So let's see. If I type it in, x raised to the power of 4 plus 2x raised to the power of 3 minus 25x squared minus 50x. Whew, long one. Okay, graph. If we had to do these by hand, we would definitely have trouble. There's 1, 2, 3, and 4. So we're going to do this 4 times. Ready? Second trace 5. Go over to the left. This one's going to take, oh, never mind. Thought it would take longer. It goes fast. First one is negative 5, 0. Now do it again. Second trace 5, but I want to go to the right. Get this one over here. And the second one is negative 2, 0. Do it again, second trace 5. This time go over here. Third one is 0, 0. And the last one, second trace 5. Is 5, 0. So I have 4 of them. I could list them as x equals negative 5, negative 2, 0, and 5. Again, these came out nice and pretty where the higher power did predict how many I am gonna have. But there could be examples where if I type them in and the higher power is 3, but my graph only shows 2. So that is a possibility. So don't think it's always gonna be perfect. But it did work out this way. So there you go.